So this is the Particles Homework Booklet question 9, and it starts off by asking us, under certain circumstances it's possible for a photon to be converted into an electron and a positron. State what the process is called. So that's just use the name pair production. A photon must have a minimum energy in order to create an electron and a positron. We're asked to calculate the minimum energy of the photon in joules and give your answer to an appropriate number of significant figures. Excuse me. So the energy is going to be twice the rest mass of an electron. We need the rest mass of the electron, we need the rest mass of the positron, but rest masses of particles and their antiparticles are the same, so I can look up in the data sheet and the rest mass energy of an electron and simply double it. That is 0.51099 in mega electron volts. So that's where the first mark was for getting to 1.021998 mega electron volts. But we were asked for it in joules, so we need to convert that into joules. So there's the 1.021998. That's in mega electron volts, so that's times 10 to the 6 electron volts, and then to convert to joules I need to multiply by that conversion factor 1.6 times 10 to the minus 19. 1.60 that should say. Let me just put that in. There you go, it now magically says 1.60 times 10 to the minus 19 joules, and that gives me a minimum energy required of 1.64 times 10 to the minus 13. So the second mark was for having that number, and the third mark was having it to the correct number of significant figures, which is 3, because that 1.60 times 10 to the minus 19, which I got from the data sheet, is to 3 significant figures. Finally then, a photon of slightly higher energy than that calculated in part B is converted into an electron and positron. State what happens to the excess energy. Well, that's going to become kinetic energy of the electron and positron. They're going to have an equal amount, they're going to have an equal share of that kinetic energy. You could get away with saying kinetic energy on its own, but if there was any implication that the photons would have kinetic energy, you can't have that. The photons have the energy, full stop. Describe finally then what's likely to happen to the positron shortly after its creation. Well, we live in a world where there are an awful lot of electrons. Everything's made of atoms. The atoms have got electrons in them, so it's very, very likely to meet an atom and annihilate. And when it does that, it'll become a pair of photons. Worth noting that those photons will each have less energy than the original photon we started with, so we won't necessarily then go on to do pair production again, because only half of the energy of the photon we started with ends up as a positron. So, and half that energy goes off and it'll annihilate with an electron, but that becomes 2 photons, and so they're going to have less energy than the original photon. So that's the Particles Booklet question 9.